science student, and in this video, I will discuss the importance of the transformer. I will answer the 6 questions and clarify in this video. The first question is, what is a transformer? Number 2, what is the working principle of the transformer? Number 3, what is the step down and step up transformer? Number 4, what are the applications of the transformer? And finally, what are the construction and parts of the transformer? What is a transformer? A transformer is defined as the passive electrical device that transfers energy from one circuit to another through the process of electromagnetic induction. It is most commonly used to increase or step up and decrease or step down the voltage levels between circuits. Now, we will proceed to the working principle of a transformer. The basic principle on which the transformer works is on Faraday's law of electromagnetic induction, or what we call the mutual induction between the two coils. The transformer consists of two separate windings placed over the laminated silicon steel core. The winding to which AC or alternating current supply is connected is called the primary winding, while into which load is connected, that is called the secondary winding. But take notes, it works only on the alternating current because alternating flux is required for mutual induction between the two windings. But when the AC supply is given to the primary windings with a voltage of V1, an alternating current flux sets up in the core of the transformer, which links with the secondary winding, and as a result of it, an EMF is induced, and it is called the mutually induced EMF. The direction of this induced EMF is opposite to the applied voltage V1. As you can see, physically there is no electrical connection between the two windings, but they are magnetically connected. Therefore, the electrical power is transferred from the primary circuit to the secondary circuit through mutual inducting. Now, I will explain the difference between step down and step up transformer. Transformers can either step up or step down the voltage. And a step down transformer, the number of turns in the primary coil is greater than to the number of turns into the secondary coils. While in the step up transformer, the number of turns in the secondary coil is greater than to the number of turns in the primary coil. Now, we will focus to the step down transformer. If there are fewer coil turns on the secondary than on primary, this is called a step down transformer. The resulting voltage in the secondary circuits will be less than the primary. For example, there are 20 turns in primary coil and 10 turns into the secondary coil. And to determine the decrease in voltage occurring in the step-down transformer, we can use a simple formula. V secondary over V primary is equals to T secondary over T primary. The V secondary is the volt secondary or voltage, while T is turns. So, V2 is equals or over 120 volts is equals to 10 turns and or over 20 turns. Then, 10 turns over 20 turns times 120 volt primary is equals to 0.5 times 120 volt primary. Therefore, our volts or the decreased volt is 60 volt. The parts and construction of the transformer. Without transformer, the electrical energy generated at generating power station won't probably enough to power up the city. That's why transformer plays a very crucial role. For example, there are no transformers, so we need to put or build a lot of power plant, and that is very hard to do because it's not easy to set up a power plant. So, in this case, transformer help by amplifying the transformer output in stepping up or down the level of voltage or current. So now we will define the parts of the transformer. As you can see, there are a lot of parts of a transformer. So the number 1 is the oil filter valve. Number 2, the conservator. Number 3, the Buchholz relay. Number 4, oil filter valve. Number 5, pressure relief vent. 6, high voltage bushing. 7, low voltage bushing. 8, suspension lug. 9, BCT terminal. 10, tank. 11, the energized tap changer. 12, tap changer handle. 13, fastener for core and coil. 14, lifting hook for core and coil. 15, end frame. 16, coil pressure bolt. 17, 8, oil drain valve. 18, jacking boost. 19, topper. 20, foundation bolt. 21, grounding terminal. 22, sked base. 23, coil. 24, coil pressure plate. 25, again core. 26, terminal box for protected devices. 27, rating plate. 28, dial thermometer. 29, radiator. 30, manhole. 31, lifting hook. And 32 is the dial type oil level. And the last question is, what are the application of the transformer? The power companies use a step-up transformer. Why? The purpose of it is to boost the voltage to 1000 volts. Then, they transmit it to a power lines. While in the household supply, we use a step-down transformer. The purpose is to reduce the large voltage supply. A step-up transformer used for starting an electric motor. It is used in microwave ovens, X-ray,